Hello guys, welcome to Learn with Venki. Uh, Today I will show how to do kinematic simulation in CATIA V5. At the end of the video, you can also can easily create this type of kinematic simulations even more better than this. So let's move on to the main video. I will cancel this one. I will open assembly file. Assembly file is must to do kinematic simulation. I have engine assembly, small assembly. In this, I have 3 pistons and 3 connecting rods and a crankshaft and a engine block. I have assembled this one like with simple constraints like offset, constants, like that. First thing, first thing, you are in assembly design. First, then you have to click on the start, then digital mockup, kinematics, TMU kinematics. Then you will enter into this workbench. Now, the first thing you need to do is assembly constraint conversion. If you want, you can give the name of the mechanism. Like I click on new mechanism. If you want, you can give engine, animation, like this. You can give, or else whatever you want, you can give. Okay, now it is created. You can see engine animation workbench has been created. So now, first we need to do the fixed part. Select the fixed part. This one, fixed part has been selected. You can see the fixed part. Then we need joints. For this, I will give kinematic simulation for only this piston and this connecting rod. Remaining I will leave because it is also similar. There is nothing more. It is like prolonging the video. Nothing more than that. If I shown one thing, you can also do for remaining two also. So first thing, have to give the revolute feature like revolute joint for this one and this crankshaft, engine block and crankshaft. First, select this. In this revolute joint is there. You can see revolute joint. This is the revolute joint. First, I will select the axis of the crankshaft. You can see the crankshaft is selected. Now I will hide this one and I will select the axis of engine block. It is like something like tough to find the axis sometimes, but eventually you will get the axis. So you can see the part 1 has been highlighted. So we are clicking on the axis of part 1. Part 1 is nothing but the crankshaft, the engine block. So now we have to again show the crankshaft from here. Then we have to, the lines tags has been selected, but we have to select the faces where these are coinciding. So I have to select the face of this crankshaft. I will hide this one. I can easily identify this face, this face, this face. Then again, I will unhide this one, part 1. Then I will select this face, which face is near to the selected face. So you can click on the offset. Offset 1 mm is okay. Then we can delete the earlier constants. They are not required. Then you have to give the revolute joint for the connecting rod and the crankshaft. First, you need to select the revolute joint. Then you have to select the connecting rod axis. Then after that, you need to hide the connecting rod because you can select the crankshaft. So now the crankshaft axis has been selected. Now unhide this and select the face which is near to the crankshaft, and again just select the face of the crankshaft which is near to this. Then again offset 1 mm is okay. So now we need another one revolute joint for crankshaft and piston. So now I will hide this connecting rod. Now I will give revolute joint for connecting on piston. For that, select the revolute joint and select this axis. You can see the piston axis has been selected. Now to select the connecting rod axis, you need to hide the piston. Then select the axis. Now the axis has been selected. Now again unhide this one. Hide the connecting rod. Select the face which is near to the connecting rod and select this face. Then again we'll hide this one. I will unhide this connecting rod and I will select this face which is near to selected one. So now offset, you can see is 1.5 mm offset, no problem. Now you unhide this one. Now unhide the engine block. Now you have to give cylindrical joint for up and down movement. For that, select the cylindrical joint, select this piston, then again hide this one. Now select the axis of this hole, what you call the cylinder, like the bore. Then okay. So now the constraints has given, but the only thing we have to give the input joint. So the first joint, which is this one, is the input joint. Make this as angle driven from 0 to 360. Okay, now we can see we got a pop-up message and we got DOF is equal to 0. The mechanism can be simulated. So now you can also try with these two. You can also get a animation which I shown earlier. So now after this, you have to do select this one, simulation, engine animation. Okay. So now simulation has been came. You can see now need to just drag like this. Make sure that whether it is going properly or not. Now click on here, insert, then make this as 0.2 and make this as replay. Then click on this play button. Now you can see this crankshaft is rotating along with the piston is moving up and down. So this is how we can create easily the animation of anything, not like a specific engine or something. You can do any animation. Make transparent. You can create any animation. So that's all for today. Thank you for watching. Please do subscribe for more interesting videos. Learn with Venki.